Okay, in the intermission, I had a quick question about what happens when you get a probability of x is less than or equal to versus strictly less than that I've been using up to this point. That's a really good question, and I think I should have talked about it before. So, say I had a normal distribution. I don't really care about the mean and standard deviation, but let's say 3 is here. Since probability is area on this graph, we actually try to look at kind of the probability of x equaling 3. So before I answer this question, what would the probability of x equals 3 be? Well, that's the area of a line, and the area of a line is 0. So the answer to that is 0. So now we are kind of interested to compare what the probability of x less than or equal to 3b would be versus the probability of x less than 3. And because the difference between these is just this, actually the probability of 3, and that's 0, you can see that actually these two are equal, which is obviously not true with a discrete distribution. It is only true of a continuous distribution. There will be something coming up when we try to compare binomial and normal soon, but for now, we're going to remember that that is the case. Okay, so we're now going to move on to the inverse normal. So, the inverse normal is just when you want to get back from a probability to the value on the axes. So, this is an exam question, and if I was to roughly try and sketch the answer to that, what I'm saying is the probability of less than d is 0.1151. So, on this distribution, I can see that kind of 30 is in the middle there, and whatever our letter value d is, it's probably somewhere like that, because my area down here, I'm told, is about 0.1, so I know it's down here somewhere. 1151. So the answer is, question is, what is this value? Now, I could kind of approximate it. I know 2 standard deviations from the mean. That's going to be 10 away, so that's going to be about 20. So it might be somewhere near there. It's going to be somewhere between 1 and 2 standard deviations from the mean, so probably somewhere between 20 and 25. But what is it exactly? So we want to ask the calculator this, and the calculator can just do this for us. So I want to go now into distribution again, but this time I'm going to go to the inverse normal. So the option 2 here, you give it a value and it returns a probability less than or between. For the inverse normal, you give it a probability and it tells you the value such that less than that is the probability you said, i.e. exactly like we're going to give it 0.1151 and it's going to tell me what the value d is for a specific mean and standard deviation. So I'm going to click 3 and it says what's the area I'm interested in. It is always the area to the left, i.e. in the negative direction. So I'm going to put 0.1151 there, and I'm going to put a standard deviation of 5 there, and I'm going to put a mean of 30 because that's my that's my mean of this distribution I'm interested in. And I'm going to click equal, click equal again, and it's given us the value. And it's actually said it is 24. Just going to double check on my answer here. Done everything correctly. Yeah. And I actually suspect that when this question was written, that value was rounded anyway. It looks so close to 24, it probably actually is a rounding of 24 anyway. Not all the answers will be nice. So I can say that the probability of x is less than 24, actually in this case, 3 single figures, 24.0, is 0.1151. And so d is equal to 24. 0.0. Now, this next question says probability of x is greater than. Now, the inverse normal calculator only does less than. So that's not quite ideal for that, but I can always change this into a less than. So if I look at my quick sketch of a normal distribution, they're getting worse. I have got a value here of e, and I've got 0.1151. There is a shortcut here for this question because I did part 1. But in general, if I want to find x is greater than e, is 0.1 is equal to 0.1151, looking at my picture, then this area here must be 1 minus 0.1151. So I can actually change this into the probability of x is less than e, which is what I need for the calculator, is 1 minus 0.1151. Now you can always calculate that value, but actually we can do it pretty much straight through the calculator. So as I said, you may, looking at this, have guessed a shortcut, but we're going to do it the long way first. So my area that I want now is 1 minus 0.1151, and I can actually type straight into the calculator in that field. And press equals, and it works it out, 8849. So click equals, and there's my value. Now I can see this is actually 40.0. So the value, the probability of x being greater than 40.0. Oh, just let's check it. Thank you for your help. 36. There we go. I rounded wrong. Thank you very much for your help. Okay, let's check. 36. Is that right? 36.0. Okay, and that is 0.1151. Now let's have a quick look at our answers here. 24 is 6 below 30 and 36 is 6 above 30, and we are really talking about the same area on either side. Because it's symmetric, it makes sense that 30 would be here, 24 would be here, and 36 would be there because it's symmetric. So that might have been a shortcut. You probably could have worked out your answer to part C without having done that, but nevertheless, we could find greater thans on the calculator. Now, for a question like this, you actually do need to go about this using kind of breaking this down and working out these answers. Or you can kind of look carefully at your graph. So I can see, let's edit that because that was not quite right. I've got 0.1151 at the top, 0.1151 at the top. So between 24 and 36, that's now 36. I can see that I've got 1 take away 2 lots of them. So actually, I can think this is going to be 1 take away 2 lots of 0.1151, which after doing a bit of calculation, you should get an answer of 0.7698, which is going to be 0.7698. So we have got 0.7698 in the middle, and think does about 0.1 plus kind of 0.8ish plus 0.1. That adds up to 1. It feels like the answer's right. It's good to do a quick check, and yeah, we got it right. Okay. So moving on to another question now. Random variable x has a normal distribution with mean 20 and standard deviation 4. Immediately I'm thinking we're talking about something like this. Find the probability of x is greater than 25. It's not a inverse normal question. This is just a standard. So we're going to go here, here, and I'm going to go to CD. I want greater than 25, so I want to start at 25. I want to go greater than forever, so I want to do 99999. My standard deviation is 4, and my mean is 20. So I get 0.106. 0.106. 0.106. Now it says find the value of d such that the probability of 20 to that value is 0.4641. There's a bit of problem solving to do here. So I'm going to draw my normal distribution. Something I'm sure teachers have said to you countless times is draw a picture. It really helps. Trust me, it really works. Now, I've spotted actually that this value here is actually equal to the mean. So there is a shortcut here. We could still do it where that wasn't equal to mean. If that was just another value, there could be another way of doing it. But actually, there is a shortcut because I know the probability of less than 20 must be a half because it's the mean. Nevertheless, similar way of going about these two questions. two ways, even if that wasn't the mean. And that is that I can see, with a bit of thought, that since 20 is right in the middle, D must be above the mean. It must be up here. We've got must have an area of 0.464. So it's quite useful if I kind of say that D must be here, and we've got an area of 0.4641 here. So with a little bit of thought, you can see that this value, 0.4641, must be the probability of less than D minus the probability of less than 20. So this is going to be equal to the probability of x is less than D minus the probability of x is less than 20. And that is equal to 0.4641. It might be tempting to go into your calculator and go to this screen and say 20 to something, but we don't know what to put in there. I could start putting some values in and see if I could get roughly close, but I don't really know what to put in there. So I'm going to have to use the inverse normal because I've got a probability and I'm working back to the value. So let's have a look what I've got here. I'm going to just insert a bit of space below. Put a dot there. Okay, so I've got an equation here. I have got that the probability of x is less than D minus the probability of x is less than 20 is equal to 0.4641. I can find that probability. If that was not 20, I could look it up on the calculator and get a value for that. Since it is 20, I can actually see that area there is 0.5. So I can say that the probability of x is less than D minus 0.5 is equal to 0.4641. Just to go back in case that some people maybe didn't quite get that, the reason I can say that between 20 and D is less than D minus less than 20, because I'm saying, what I'm doing is I'm going less than D all the way down, and then I'm taking away from that less than 20 just to be left with this part. So that's a way, if you didn't quite get that, I just recapped that. Okay, going back to what we were just working on. The probability then of x is less than D is going to be equal to 0.4641 plus 0.5, so it's 0.9641. And now we're in the classic inverse normal situation, so I can go here, menu, into distribution, inverse normal. I want an area of 0.9641. I want my mean to be 4, and my mean to be 20, my standard deviation to be 4. So click equals, get my answer, 27.2. So therefore, D must be equal to 27.2. And as usual, let's have a quick check. Does this make sense that that's about 27? Yeah, that looks about reasonable, and that kind of thing. It's actually roughly 2 standard deviations above, which is why we're getting nearly 0.95, not quite, but in that kind of region. It's useful to kind of have a feeling that answer might be reasonable. Okay, let's see what we're going to move on to. I am going to do this last example in this video before moving on to the next one. Okay, and I'm going to do this video because this is an example of a question which kind of goes some different places. Okay, first question here. Find the probability of x is greater than 53. It is worth me noting that in the new specification, that's far too generous. This is going to be a 1-mark question because it's simply just typing into a calculator. In the previous spec, there was a lot more work to do. But let's do this. So we've got mean 50, standard deviation 2. So go back into my normal distribution, normal CD. Lower is 53. And I want to go up to 9999. Oh, I need to change my standard deviation is 2. And my mu is 50. And click equals. And I get 0.0668. 0.0668. 3 significant figures. Never going to be 3 marks. Right, this is to do with the kind of language, which is why I wanted to go through this. Find the weight that is exceeded by 99% of the bags. It's very easy to accidentally write down the wrong thing here. It's very easy. We first need to interpret what is it saying. What is the value that is exceeded by 99% of the bags? With a bit of thought, you can see we need that to be 99%. We need 99% of them to be above this point. So this is going to be my value D or whatever, and because I want the probability of X is greater than D to be 0.99. That must be 99%. So below it must be 1%. Probability of X is less than my value must be equal to 0.01. Into my calculator, I need an inverse normal now. We've done this a few times. Inverse normal. Area is 0.01 to the left of it. Mu is 50. Sigma is that, and we get 45.34. So D is equal to 45.34. Okay. This was the reason I really wanted to show this question, this last question here, because you need to do a bit of careful thinking as to what this is actually asking you. We have got 3 bags being selected at random. Previously in this question, we've just had 1 bag. Now we've got 3 bags. We want 2 to weigh more than 53 and 1 to weigh less than 53. So in a sense, I've got 3 bags. And I want 2 to be more than 53, which I know has a probability of 0.0668. And I want 1 to be less than that, which is going to be 1 minus this. So I've got a probability of 0.068. And I've got 3 bags, and I want 2 to be yes and 1 to be no. N, P, 2 yes, 2 no. With a bit of thought, you're like, this feels like a binomial distribution. And it is. It's a binomial distribution using a value from a normal distribution, which is a very common exam question. And you need to be able to spot when those things are coming, because nowhere in this question does it say binomial. So binomial 3 with a probability of yes, actually X is a poor choice. I need a new distribution. Let's say Y, 0.068. Thank you. That's why you're all here, doing a great job of checking my maths. Good. Okay. And then with a bit of kind of looking at the situation, we want to find the probability that Y is equal to 2, i.e. 2 out of the 3. Now, at this point, it's not the hardest kind of binomial to calculate. We could just calculate it straight on the nose. We've got 3 options. We want 2 successes. And we have got 0.0668 happens twice. And 1 minus 0.668 happens once. And you could just type that straight into your calculator. Or, of course, you could go to binomial PD. We're not doing cumulative. We want an exact probability of something. And just go for a particular one. And we want 2. N is 3. And this was, I could have actually stored this value from earlier, but it's going to be good enough. 668. And find the probability of that. So the probability of 3 bags and ending up with 2 weighing more and 1 weighing less, 0.0125. 0.0125. So that is going to be 0.0125, and that will be my probability of that. Okay, at this point we've kind of talked through the inverse normal distribution. That would probably mean you have got enough to be able to having a good go at exercise 3C, and you should at this stage practice that. Exercise 3C, which is on page 46. And my recommended questions for exercise 3C that you should have a go at are questions 1, 4, 5, and 9. Okay, so I recommend you have a go at those questions. I am going to stop the video.